this then, electromotive force and the potential difference. Let's go forward. Now the next thing you guys need to understand is that
Are you sharing your screen?
is it not sharing? Oh no.
No, so I can't see it.
Wait, let me see. Okay. Can you see now?
Yes, sir. Thank you.
Okay. Okay. So now one thing that I would like to tell you is that, and that's very essential to understand, write a note here, that current always goes from a point of higher potential to a lower potential. What I mean by this is that suppose that there is a resistor. On one side of resistor, the potential is positive 500 volts, and here it is 0 volts. Because positive 500 is greater than 0, then the current would go like this. But if suppose this point is 500 volts and this point is also 500 volts, then current in this would be 0. Why? Because technically, if there is no potential difference, where would current go? It will always go from higher to lower, but not in this one. All right? Now, for example, in a question, it says, points A and B are connected with an ammeter which shows a 0 current, right? So they have given point like P and Q, and then in the middle we have A, and then there's in the wire R and S, and here we have P, and between this we have an ammeter. So it says, what is the reason for this? Now, so there are two possible answers for this, right? So I'm going to write one that most of the people write, which is a wrong answer. which is, they say, it could be because ammeter has infinite resistance. Now, why is this wrong answer? Because in reality, there cannot be infinite resistance. Also, ammeter has very low resistance. So this is a wrong answer. Never write this. The right answer for such question would be that current cannot move between points of same potential. Walaikum salam. So current cannot do that. You need to remember that. So you need to remember that this means that A and B have no potential difference between them. Has to be zero. That's why current would not go. Is that clear, everyone? Aman, Aisha, Hamad.
Yeah, sir.
Okay, good. Now, the next thing, before we go why this is so important, I'll just put a star here. You also should put a star here. Why this question is so important once we've done significant, because without doing a lot of electricity, we can't solve its questions. So once we do it significantly, then we'll start solving. So now we look at the electrical resistance, right? Now electrical resistance is basically the opposition to flow of current. Like resistance is proportional to voltage, and resistance is inversely proportional to current. There is certain condition for this, though not always. But
Sir, did you start this just now?
Yes. So resistance is equal to voltage over current, and I just want to tell you that this equation that we know is only true for ohmic conductors. So you can't use this equation everywhere, so remember that. And I'll tell you what ohmic conductors are in a bit. Now the symbol for resistance is R, and the SI units are ohms. Like that. Please write this down. Okay. All right, now, so technically then, we also need to, there will be a question where they will say define ohm, and when this question comes, you're gonna say that 1 ohm is the resistance of a component when a potential difference of 1 volt drives a current of 1 ampere through it. Okay. Now this question readily comes, so you should remember that. Okay. Now, then another question, which is basically derive an expression I equals to NAVE also is there. So we need to learn that this is very important. So suppose we have a wire which has a cross section, I'll write it like this, A, and wire has length L, and through the wire current I is crossing. Okay. So the couple of things that before we do, we need to remember. I, N, A, V, and E. So we need to know what these are. So I is the current passing. N is the number of electrons per unit volume. Okay, let me just move this here. And I just want to tell you that this basically, sometimes the examiner also calls this as electron density. Also, I'll just put a gap here, so I need to explain this a bit more. Electron density is basically a unique value for each material. So it basically means in a unit volumes, if I cut 1 meter cube of this wire, how many electrons will it contain? This is what it means. Now A is the cross sectional area. V is called the drift velocity, which means how fast the electrons are drifting inside, and E is the charge on an electron, or elementary charge, what you want to say. Okay, so with these things we should know. Now the derivation starts from number 1, so I'm going to do one by one. I is given by, current is given by charge over time, right? Now currently we don't have time, neither we have charge. So what you want to do is, we know that in the second section, charge itself will be N the total charge that is available in this is n, which is the number of charges. Okay, I'll write like this. Okay, I'll say charge per unit volume will be equal to n, which is number of electrons per unit volume, times the charge on one electron will give me charge per unit volume. So this is second. And then third, we're going to say that only charge, which is Q, will be when n times E is multiplied by volume. Right, like that. This is the length, by the way. Now, fourth step is going to be when I'm going to say that because volume V is cross-sectional area times length, and now I'm going to go back, like now I'm putting it back, which means that the charge will be equal to, charge will be equal to n times E times A times L, because I just basically, instead of this V, I put A times L, right? And in the fifth step,
Sir,
yes, sixth step.
I don't get how charge over volume is n times E.
Because n is number of electrons per unit volume. So if there are like 500 electrons, 500 number of electrons per unit volume, right? Like this. And I multiply the charge of one electron, won't you get the total charge over volume? Do you get my point?
Yes.
So
Yeah.
this whole thing is n times this is E. Do you understand?
Yes.
That's why. Okay. So in sixth step, because current is charge over time, so you see I'm going back in the same loop. It is going to be n times E times A times L divided by T. Why? Because current was charge over time. Now if you look closely here, length over time is velocity, which means in the seventh step, say current is equal to n times E times A times V. So rearranging this would cause it to be NAVE. Do you guys understand this? Okay. So I have basically made it simpler for you. Of course, you can take less steps, like you can step 5, step 6, even step 4 is unnecessary. But once you learn it, that how I got each value, you'll understand. Is that clear?
Yes, sir.
Okay. But I feel like that this would make it, you can write it down, and then I'll make just...
What did you do in step 6?
I basically put the whole charge value, you see, this into this. Do you get it?
Oh, okay.
And then I got length over time, which is the drift velocity. Okay. So in short, if you want to remember this way, you just need to remember that I is Q upon T, and Q is basically number of electrons per unit volume, right? So I'm going to multiply the charge and electron and volume, and then Q will be n times E times area times length, and then I'm going to put it right here, and when I do that, I'm going to get I equals to n times E times A times L over T, and from here length over time velocity, so it will be NAVE. This is basically the derivation. It is only 3 steps, but I have made each step in a detailed version so you guys can remember. Okay, any questions?
Sir, go bound to copy it.
Yes, copied.
How did you remove L over
sir,
here?
Because Ahmad, velocity is displacement over time, right?
Yeah.
So
Okay.
so if there is displacement, oh my god, if there is like displacement over time here, I can actually put this right into this. Do you understand? That's all. Okay. So speaking of this then, now we'll move to the last part of this topic, which is called why? Why? Your internet is working? Damn. हो गई? हाँ?
It was working.
अभी तो चल रहा था, अभी क्या इसको हो गया?
अभी कुछ हुआ है in a second.
मेरे अब्बा ने ऊपर से लाइट बंद कर दी होगी, उसने लाइट बंद कर दी होगी। एक तो ये इनको बड़े तकलीफें हैं ना।